So here we go again. Now we're moving on to Chapter 7. Chapter 7, we're talking about nth roots and rational exponents, and what does this mean and how does this work? We're going to be working on this for a couple days. So first is a definition. An nth root of the variable a is written as the nth root of a, where n is the index of the radical. So how does this work? Well, first of all, we've all seen the rational notation of the square root of a, but we always assume that there's a number 2 in that square root. We don't write it because it's assumed to be a 2, but that's the square root of a. Before I go on, I'm going to stop and say these notes, you can print out the PDF and you can fill in as we go along. But as I have here, I have rational notation and I also have exponential notation. Well, what does the square root of a look like as an exponent? That is a to the 1/2 power. Now this might be new to you. You may have not seen this before, but this is exactly what we're doing. A to the 1/2 power is exactly the same as the square root of a. Well, I can take the square root of something. Well, what else can I do? I can take the cube root of something. The cube root is the 1/3 power. I can take the 4th root of something, and at the same time, that's the 4th root to the 4th power, and I can continue this till I can get to a generic nth root of something, which is to the 1/nth power. These are exactly the same thing. We're doing the same process. What's different is the notation, the way you write it. So that's the nth root, and that's the rational exponents. That's the notation as a fractional exponent. A rational exponent means it can be an exponent written as a fraction. The next thing I want you to do is this next page that I have here is in your course pack. It's in your course pack on page 706. Have these memorized. I want you to memorize the first 20 squares, the first 10 cubes, the first 5 quartics, the first 5 quintics, and the first 5 sextics. It's something like that. I don't remember. To the 6th power, to the 5th power, to the 4th power. Know these because when we take the 6th root of 4096, you need to know that it's 4 or -4. And so you need to kind of have these numbers memorized. You need to know what they're doing. So now that I'm memorizing these numbers so that I can reduce them if necessary, or I can multiply them out, what's the uses of this? What does this look like? Well, this next slide is the main thing. So let's look at this. Rational notation and exponential notation. So what I'm doing is I'm looking at roots and powers. Roots and powers. When I look at rational notation, the root is always in the radical sign. The root is always in the radical sign. The letter n is my root. The power is the power that it's being raised to. It's the exponent. So the m is the power. Well, let's look at exponential notation. The exponential notation, the root, or roots, let's go with just root. The root, the square root, the cube root, the 5th root, is always the denominator. It's always the bottom number of that fraction in the power, in the exponent. The power is the numerator, the top number in that exponent. So I have rational notation, I have exponential notation. Let's notice the base is always a, or some number. Let's see what that does. Here we go, example 1. Evaluate the expression without using a calculator. I want 9 to the 3/2 power. 9 to the 3/2 power. Well, what does this tell me? Well, I'm going to look at this as 9, and I'm going to first look at the half. So if I break this up as 9 to the half to the 3rd, that's still 9 to the 3/2 power. But that half, 9 to the half, is actually the square root of 9 to the third power. The square root of 9, well, that's 3. So now this is 3 to the third power, which is 27. That's how I can do these by hand. I can kind of use what I know. I know that the 1/2 power is square root. I can take the square root of 9. So the square root of 9 is 3. 3 to the third is 27. Let's look at this next one. I want 32 to the negative 2/5 power. Well, the first thing I'm going to take care of is that negative. And so this is going to be 32 to the 2/5 power. And I can do this in a couple different ways, but I'm going to break it up as 32. Excuse me. Let me rephrase that. I'm going to break this up as 32 to the 1/5 power squared. Again, this is doing the same thing. I'm breaking up the fraction. I'm deciding to do the fifth before I do square. Why? Well, let's flip back one page. If I go back one page, if I look at 2 to the 5th power, 2 to the 5th power is 32. So my purpose of taking the 5th root of 32, and notice that becomes the 5th root of 32 squared. That 5th root of 32 now, excuse me, that's 1 over. Let's rewrite that. Excuse me, I made a mistake. Try that again. This is 1 over the 5th root of 32 quantity squared. So that's 1 over, as I just showed on the other page and I circled in green, 1 over the 5th root of 32 is 2. 2 squared is 4, and this is all under 1, so my answer is 1/4. So the first thing I did with this problem, again, is I took care of the negative, and I flipped it into the denominator. I broke up my fraction into the 1/5 and to the 2nd power because I recognize that 2 to the 5th is 32, so I took the 5th root of 32 and I got the number 2. I then took the 2nd power, and so I got my answer to be 1/4. So let's look at another example. Example 2, evaluate the expression without using a calculator. Okay, well, let's do the same thing. The 4th root of 16, 16 to the 1/4, I'm already reading it the way. The 16 to the 1/4 is the 4th root of 16. That's asking what number times itself 4 times is 16? Well, that's 2. So my answer is 2. Now, you're going to say, well, what happened to that 1? Because this wasn't just 1/4. Well, you can think of that as the 4th power, the 4th root of 16 to the 1 power, so 2 to the 1 power is 2. I can still do that if I want to keep that 1 hanging around, and it still makes sense. Let's look at letter B. Letter B, again, I notice that I'm going to take the square root because I have the divide by 2. And so I'm going to look at this as 4 to the 1/2 power cubed. So that's the square root of 4 cubed. So that's 2 cubed, which is 8. And I'm just breaking this down and I'm trying to figure it out as much as I can. Well, I look at this and how am I making the decisions that I'm making? Well, look at letter C. Do I really want to take 16 to the 5th power, or do I first want to try to take 16 to the 1/2 power? It seems to me 16 to the 1/2 power is easier than 16 to the 5th power. Well, 16 to the 1/2 power is the square root of 16, and then I'm going to take that to the 5th power. 16, the square root of 16 is 4 to the 5th power. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. 256 times 4 is 1024. That's 4 to the 5th. Now, if I don't have that memorized, I can come back over here and see that 4 to the 5th is 1,024. That's why we gave you this sheet, so you can kind of get to know these and get to memorize them. Ignore that bell. And so 1,024 is my answer. So let's try letter D. Let's do this one in green. And again, the first thing I'm going to take care of is I'm going to take care of that negative right there. And I'm going to write this as 1 over 8 to the 2/3 power. Get rid of the negative. I'm then going to go ahead and write, ignore that. I'm then going to go ahead and write this as, again, what's easier, 2 to the 2nd or the cube root of 8? Well, for me, the cube root of 8 is easier. So this is 1 over 8 to the 1/3 squared. 8 to the 1/3 is the cube root of 8, and I'm going to square that. The cube root of 8 is 2. 2 squared is 4, so my answer is 1/4. I work through this step by step. I break it down. Am I showing every single step? Yes. Why? Because I'm the math teacher and I'm showing you where my thought process is going. If you can simplify this by skipping a step or two, can you? Yes. Do I want you to plug this into your calculator? No. I want you to do this without a calculator. Use that brain of yours. Okay? So that's evaluating expressions without a calculator. I want to transform into radical notation first. What else can I do with this? Well, example 3, evaluate the expression using a calculator. Close your eyes. Do not look at the man behind the curtain. Let's try this again. Sorry about this. One more time. Okay, I got rid of that one already. Good. So evaluate the expression using a calculator. Round the result to 2 decimal places when appropriate. Transform into exponential notation. Here's my handy dandy little calculator. Let me move this over so I can see it. So here's A and here's B. Here's my calculator. Could I go ahead and say, oh, I want to take the 4th root of 5, and then I want to go ahead and I want to cube it? Yeah, I could do that. Is there an easier way? And let's talk about that easier way. That easier way is to notice, recognize, and see that my base is 5, my power is 3, my root is 4. So I want 5 to the 3/4. So I go to my handy dandy little calculator, and I'm going to go ahead and say 5 to the, now this is where you have to be careful. I want parentheses 3 divided by 4. Close parentheses. 5 to the 3/4 power. When I do 5 to the 3/4 power, I get 3.34, which is my answer. So round to 2 decimal places is 3.34. Now, what if I forgot those parentheses? What would it look like if I forgot those parentheses? Well, if I did 5 to the 3 divided by 4, I get 31.25. Now, that's very different. Why is it different? Because what you're doing is 5 to the 3rd power, finding that answer and dividing that answer by 4. That's not what I want to do. What I want to do instead is take the 4th root of 5 and cube that. When I take the 4th root of 5 and cube that, I do get 3.34 when I round to 2 decimal places. Be very careful to use the parentheses. Let's try the next one. I want the 5th root of negative 22nd, the 5th root of negative 26 squared. My base is negative 26. My power, my exponent, is 2/5. So again, I go to my handy dandy little calculator. I'm going to clear, so this is all that I see. Now again, I have to be very careful. I want my power to include the negative, so I need to open a parenthesis and do negative 26. Close parenthesis. I want to the power of open another parenthesis for the power, and when I want the power to be 2 divided by 5, that's what my problem should look like going into the calculator. When I hit enter, I get 3.681199371. So my answer to 2 decimal places is 3.68. Remember, I need a parenthesis around the negative 26 to make sure that I take the power of the negative. I need parentheses around the 2/5 to make sure it's 2/5 power, and not to the second power take the answer divided by 5. Be very careful that this is done in this process. One more time, 2 more examples. Evaluate the expression using a calculator. Round the result to 2 decimal places when appropriate. Again, what I want to do, my negative is outside the parentheses this time. My base is 3, so this is 3 to the 2/5 power, and then I want it negative. So I go to my calculator, and this is when I can play with things. I'm going to scoot this over so I can see it all. Because I can use what I know about the calculator to make sense to me. Again, hit clear. I want the negative out front. I want 3 to the parenthesis, 2 divided by 5 power, and there's my answer. Negative 1.518455574 to 2 decimal places is negative 1.55. Again, the negative, the way the calculator sees this is this negative is outside of what's being taken the power of. So that negative is what is stuck in the front here. If I put it in parentheses, I'd end up with a different answer because that negative 3 would be squared, and then I want the 5th root of that, and I'd come up with a very different answer. So negative 1.55 is what that is looking for. My last problem, and yes, that's my last problem, my base again is 3. My power is 4. My root is 3, so 3 to the 4/3. Go to my handy-dandy little calculator. I want 3 to the open parenthesis 4 divided by 3. That's not a 3. That's a 3. And I get 4.3267, blah, 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 blah. And so that's 4.33 to 2 decimal places. That's all the notes that I have for you at this time. Please bring your book, and I'll see you tomorrow.